I owe entirely to the Vedantu team. It's not just the in-depth subject matters that were taught to us, but also the exam-specific strategies we were asked to use. Whatever.
Done? Okay. Hi guys, this is Saurav here and welcome to another session for the electrochemistry part on the Vedantu channel of YouTube. We have been doing a lot of such sessions and this is the fourth lecture, and in this session we would be discussing Nernst equation, a part of Nernst equation. Okay, and thank you Swasti. I'm very happy that you guys are joining us over here today and I can see a lot of new faces. Hello Anit, क्या हाल चाल है भाई, क्या हाल चाल है आप लोगों का? I hope you are doing good and let's take up something which is like a very fearsome topic in electrochemistry. इतना fearsome है नहीं, but a lot of people are afraid of it. Okay, so hello Danish, hello Ajay, hello Rishabh, hello Chirag, hello Aman, hello Saloni. So it's very nice to see you guys over here, and before we move ahead, I just want to tell you that you just saw the advertorial about Nivedya. She was our long-term student and we are having a long-term plan for the students who are currently not with us. So Vedantu 1-year long-term course is one of the most powerful IIT JEE programs in the country, and if you are willing you can explore that. The links would be there on the description page. Please do like, share and subscribe. ये मैं हर सेशन में बोलता हूँ, लेकिन ये प्लीज आप कीजिए so that you can always be updated with the awesome content that goes. Okay? So अभी तक हमने क्या किया है? What we have done until now? We have done galvanic cells. So today, कल last session में Nernst equation आता था. आज हमने Nernst equation पूरा खत्म करना है and we would be discussing about the characteristics of Nernst equation. What are the different characteristics of Nernst equation and what are different characteristics of galvanic cell? ये हमने थोड़ा सा पिछले क्लास में कवर किया है. Okay, so hello Rishabh, hello Amandi, hello Indrajit. So let's without wasting any time start today's session, and आज का session हम problem से start कर रहे हैं. So keep a pen and a paper ready. We would be starting the session with a few problems and then we'll go to Nernst equation just to check what you have learned in the last session. Okay, so याद रखिए, try to be as responsive in the chat box. It will be amazing. So the first problem is here. If E naught Ag plus Ag is 0.8 volts and that for E naught H plus H2 is 0.0 volts, then for a voltaic cell constructed using both, what would be acting as a cathode and what would be acting as an anode? Okay, so to solve this question, I need to first ask you guys, okay, so to solve this question, just a moment, there's something which is not right. Just a moment guys, there is a small issue over here. Okay, sorry guys, just a moment. I'm also trying to find out. Okay. Okay. So there was the system has become slightly overly responsive. So अब देखिए, the question is E naught Ag plus changes to Ag is 0.8 volts and E naught H plus changing to H2. First and foremost हमें ये identify करना, we have to identify that this represents reduction or oxidation. So this represents reduction. You can see that Ag plus is changing into Ag and H plus is changing into H2. So this represents reduction. Okay, if this represents reduction, these values, these E naught values represent reduction potential, standard reduction potential. You can see that naught is given, so it represents standard reduction potential. So this E naught value represents standard reduction potential, SRP बोलेंगे या फिर SOP standard oxidation potential भी बोल सकते हैं. Now when I construct a galvanic cell or a voltaic cell, one of them has to act as a cathode, one of them has to act as an anode. Now which one would act as an anode and which one of them would act as a cathode would depend that if the sum of the oxidation and reduction potential turns out to be positive. So whatever we are wanting to have as an oxidation or reduction electrode or oxidation half cell or reduction half cell or cathode or anode, हमें ये देखना होगा कि उनका सम पॉजिटिव आना चाहिए. So if I take E naught cell, it should come positive. It should come positive. So if to have a positive value, what I should do, I should take oxidation. I should take oxidation of hydrogen and I should take reduction of silver. Try and understand. Hydrogen, one of them has to undergo oxidation. मैं इसको अगर oxidize कर, if I oxidize this, if I oxidize hydrogen, it will still be 0. If I oxidize silver, it will be minus 0.8. Okay. If I oxidize silver, this value will become minus 0.8. So if I oxidize this and keep it reduced, the total sum will be minus 0.8. Minus is not favored. Minus E cell should always be positive. So in that scenario, this one should become anode and this one should become cathode. Okay, so hydrogen electrode will turn out to be anode and silver will become cathode. So इसको आप अच्छे से समझ लीजिए. This is E naught. This is E naught. ये reduction को दिखा रहा है. This is also showing reduction. अब इसमें से मैं एक को उल्टा कर दूंगा so that उसको मैं oxidation बना दूं. Okay? उसको मैं oxidation बना दूं. मैं किसको उल्टा करूंगा ताकि दोनों ये voltages का sum positive आ जाए. अगर मैंने इसको वैसे ही रहने दिया एंड इसको मैंने उल्टा कर दिया, then the sum will become minus 0.8. अब अगर मुझे पॉजिटिव चाहिए तो मैं किसको उल्टा करूंगा, मैं इसको उल्टा करूंगा और इसको वैसे ही रहने दूंगा. इफ आई कीप इट लाइक दिस तो ये कैथोड हो जाएगा एंड ये एनोड हो जाएगा. ओके, सो दैट इज वेरी वेरी सिंपल. So this will become anode, this will become cathode. What will be the E naught of the cell? E naught of the cell will be, this will be 0 plus 0.8 volts. 0.8 volts. Okay, 0.8 volts. Ritika, Ajay, Anit, Shreya, very good. This is a very very simple question. Very simple question. Okay. Now, let's move on to next question. The next question is this. If a cell is constructed with zinc and copper electrodes where E naught of zinc is minus 0.76 and that of E naught of, sorry, yeah. Okay, so this has to be, this one is not zinc, you consider it to be Cu2 plus changing into Cu. Okay, you consider it to be Cu2 plus changing into Cu. So zinc and copper electrodes where E naught of zinc 2 plus is minus 0.6 and that of E naught of copper is 0.34, then what will act as an anode, what will act as a cathode? Again I have to do the same thing. I have to take the sum of these two in such a manner that I get a positive value. Okay, I will get a positive value. I have to make one as oxidation, one as reduction. I can see that zinc 2 plus zinc में change कर रहा है, तो क्या हो रहा है? Zinc 2 plus zinc में change कर रहा है, तो क्या हो रहा है? This is reduction. ये किसके लिए दिखाया गया है? Reduction के लिए. E naught Cu2 plus Cu, this is also shown for reduction. Now I cannot have two reduction reactions. दो reduction हो नहीं सकते हैं, एक reduction होगा, एक oxidation. तो किसको हम oxidation बनाएंगे? Who should be made oxidation? Who should be made oxidation? I will, जिसका oxidation होगा उसको मैं reverse कर दूंगा. तो मैं इसको अगर oxidation बना दूं, if I make this oxidation, then this voltage minus 0.76 will become equal to plus 0.76 volts, and copper will change to 0.34. Copper will still remain as 0.34, and इन दोनों का sum कितना हो जाएगा? So cathode क्या हो जाना चाहिए? Copper, and what will be an anode? Zinc. Wherever oxidation takes place, it will be anode. Wherever reduction takes place, that will be cathode. ठीक है? Very good. So a lot of people have given the right answer. A lot of people have given the right answer. So I will change one of them into oxidation, which will give me a positive value. So remember, which equation are we using? We are using this equation. E naught cell is equal to E naught for oxidation plus E naught for reduction. So I'm adding the oxidation potential and reduction potential. Okay, जिसका reverse किया उसका oxidation. Yes, Shiv. Okay, very good. So this is very simple. What will be the E naught of the cell? E naught of the cell कितना हो जाएगा? 0.76 plus 0.34. That will turn out to be 1.1 volts. This also answers our question जो आप लोगों ने हमसे voltaic cell के discussion में पूछा था. Okay, when we were discussing voltaic cell, a lot of people had asked this question that, sir, why do we take zinc as anode and why do we take copper as cathode? Okay, the reason is this. If I take zinc as anode and copper as cathode, I am getting a positive value of E naught. If I take it the other way around, I would get a negative value, which will not be an favored scenario. ठीक है? Asmit, Ajay, very good. This is the right answer. Chalo. Let's take question number 3. Okay. So I'm a little sorry for this fact that ki thoda aaj technical issues hain. Okay. So bear with me. Problem 3 lete hain. Problem 3 padhiye kya hai. For the reduction of nitrate in aqueous solution, E naught is plus 0.96 volts. Okay. For the reduction of nitrate in aqueous medium, E naught is plus 0.96 volts. The value of E naught of some metal ions is given below. जैसे कि vanadium 2 plus changes to vanadium is given as minus 1.19, Fe3 plus changes to Fe minus 0.04, Au3 plus Au is 1.4, Hg2 plus to Hg 0.84. Okay. Question is, then which metals would be oxidized by NO3? Which metals would be oxidized by NO3? That means I have to, okay, which metals would be oxidized by NO3? So I have to oxidize all of them. I have to oxidize all of them. If I oxidize all of them, what I have to do? ये क्या दिया गया है? Can you guys tell me what is given? This is given for reduction. This is given for reduction. Now ये दिया गया है for is oxidized. So this is acting as a oxidizing agent. That means NO3 minus is getting reduced. So ये वाला part तो ऐसे ही रहने देते हैं. We are keeping this as like that. So it is given for reduction potential. E naught of reduction दिया गया है. E naught for reduction is given, which is equal to 0.96. Now, in which oxidation reactions will I add over here? I will get positive value. So I will change this to plus 1.19. I will change this to 0.04. I will change this to minus 1.4. I will change this to minus 0.84. Okay? Okay? So now these are my oxidation potential values. These are my oxidation potential values, which I can add to this to get a positive value. किसको add करेंगे कि positive value मिल जाए? 1.19 plus 0.96, I will get a positive value. Yes? Okay? 1.19 plus 0.96, I will get a positive value. 0.04 plus 0.96. Yes? I'll get a positive value. I'll get a positive value. AU will become minus 1.4. No. AU, not possible. The last one kya hai? Minus 0.84 plus 0.96. Correct. Okay. All except AU. Yes. All except AU. Okay. So Swasti, this is very, very simple. Now, a major problem that kids face, okay, yes Darshan, it could be vanadium or iron or mercury. Now, a major problem that kids face is somewhere over here. Can you see that there are two electrons which are exchanged? 3 electrons, 3, 2. Now, never ever take into consideration these electrons as long as you are working with E naught. As long as you are working with E naught, whatever number of electrons are given out or taken in, don't worry about them. This we will discuss in one of the cases of Nernst equation, that is which formula you need to use. Since you will have so many formulas, so कौन सा formula आपको use करना चाहिए, ठीक है? So that is a major question that you should be able to answer कि यार कौन सा formula use करना चाहिए किस लिए, okay? Why do we need positive values? We need positive values क्योंकि एक को तो ऑक्सीडाइज करेंगे और एक तो उसका रिडक्शन का दिया ही गया है. सो आई नीड रिडक्शन प्लस ऑक्सीडेशन पॉजिटिव होना चाहिए. ओके, चलिए नेक्स्ट क्वेश्चन पे चलते हैं. नाउ नेक्स्ट क्वेश्चन, आई होप यू वुड बी एबल टू सॉल्व दिस क्वाइट इजीली. ओके, चलिए देखते हैं. द क्वेश्चन इज दिस. Based on the following information, arrange the following metals A, B, C, D and hydrogen in the decreasing order of ability to act as reducing agents. In the decreasing order of ability of acting as reducing agents. Now, I have not given you any potential values. I have not given you any potential values. I have just given you 3 statements. Using these 3 statements, how can I arrange them in the order, decreasing order of acting as reducing agents? The first thing that I need to answer is ability to act as reducing agents means ability to undergo oxidation. It very well means if I am saying that a certain substance is a good reducing agent, that means it is giving out more electrons. Okay, or it is giving out electrons quite easily. Okay, so ability to act as reducing agent is the same as ability to undergo oxidation, and it means I would have higher value of E naught oxidation. It means E naught oxidation will be higher. जितना ज़्यादा E naught oxidation रहेगा, it will act as a good reducing agent. That is the reason group 1 metals like lithium, sodium, potassium, they act as good reducing agents because they can undergo oxidation quite easily. Now, if I want to answer this question, let's look at only A, B and C react with HCl. How do we use this information? If A, B and C react with HCl, any of them, A or B or C, if react with HCl, they will form a chloride and release hydrogen gas. They will form chloride and release hydrogen gas. Shreya, let's hold on that to that thought, it will release hydrogen gas. Now it will change to A plus or B plus or C plus. That means it is undergoing oxidation in preference to hydrogen. हम ये बोल सकते हैं A, B, C if are releasing hydrogen from HCl, that means A, B and C are undergoing oxidation and they are acting as a reducing agent. So that means A, B, C should be above hydrogen in the electrochemical series. Okay, A, B and C should be above hydrogen in the activity series. इनका oxidation potential value इससे ज़्यादा होना चाहिए. Only then it will oxidize in preference to hydrogen. Now next, when C is added to the solution of metal ions, metallic B and D is formed. So C is added to a solution of B plus, D plus, A plus. Okay, what we are obtaining is B or D is precipitated and C is changing into C plus. Okay, C is changing into C plus. It means C is undergoing oxidation and is acting as a reducing agent for B and D. C is undergoing oxidation and it is acting as a reducing agent for B and D, but not for A. Not for A. So that means A should be above C in its ability to act as a reducing agent, but C, B and D should be below C in acting as a reducing agent. अब देख लीजिए, C is reducing B and D, but C is not able to reduce A. That means C, B और D को reduce करने की ability रख रहा है, and it should be before what? B and D. Okay. Metal C does not reduce AN plus. Metal C does not reduce AN plus. So that also suggests this is the order. Now if I have to incorporate पूरा अगर मैं ट्रेंड लिखना चाहूँ हाइड्रोजन को साथ लेते हुए, then I will say A should be over here, C should be over here, B should be over here, followed by hydrogen, followed by D. Okay, you can see that A, B and C react with HCl, but D is not reacting with HCl. That means D is below hydrogen. So Anit, no, it is incorrect. Okay, it is incorrect. It is A, C, B, D, and see, D is not reacting with HCl, so D should be below hydrogen. Okay, B should be below hydrogen. Okay, I hope this is understood. This is a very beautiful question, simple question. Has everybody understood this? If you have, please tell me in the chat box. Yes, Swasti. Okay, chaliye. So let's move on to the next question. Next question भी similar चीज पे based है. Okay. Okay. Now let's look over here. The position of some metals in the electrochemical series in decreasing electropositive character. What is the meaning of electropositive? Can you tell me what is the meaning of electropositive? ये अपने you have read this thing in periodic properties. What is the meaning of electropositive character? Electropositive character means ability to lose electrons. Ability to lose electrons. Okay. It is ability to, very good Ritika, ability to lose electrons. That means ability to undergo self-oxidation or ability to act as reducing agent. Okay, ability to act as reducing. Very good, Amandeep. Various ways are there to understand this. Electropositive character एबिलिटी टू अंडरगो ऑक्सीडेशन, एबिलिटी टू लूज इलेक्ट्रॉन्स, और इलेक्ट्रॉन्स जो लॉस होंगे, इफ इलेक्ट्रॉन्स आर बीइंग लॉस्ट तो इलेक्ट्रॉन तो बैठे नहीं रहेंगे, सो इलेक्ट्रॉन्स वुड बी गेन्ड बाय समथिंग. If their ability to lose electron is more, that means its ability to reduce something is also more. Okay, so it is given as magnesium's ability to reduce anything else is highest, the least ability to reduce something lies with silver, or silver does not want to undergo oxidation. Now let's read the statements. Please read the statements. So what will happen when a solution of, okay, so there's a, what will happen when in a solution of aluminum nitrate copper spoon is added? Okay, the question is partly unfinished. Okay, so it is incomplete. What will happen when in a solution of एल्यूमिनियम नाइट्रेट कॉपर स्पून इज एडेड? मैं एक कॉपर का बना हुआ स्पून लेता हूं, आजकल कॉपर के यूटेंसिल्स मिलते हैं. आई टेक अ स्पून ऑफ कॉपर एंड एड इट टू or place it in a solution of aluminum nitrate. I have a solution of aluminum, I put a copper spoon and stir it. What will happen? So copper इस तरह का present है, Cu, and aluminum nitrate Al. This is aluminum nitrate. What will happen? Can copper undergo oxidation and reduce aluminum is the question. Can copper undergo oxidation and reduce aluminum is the question. So the spoon gets coated with aluminum. No, the spoon would get coated with aluminum only if aluminum is reduced. Only if aluminum is reduced. And can we see over here, copper is over here and aluminum is over here. So aluminum is a better reducing agent as compared to copper. So this will not happen. An alloy of aluminum and copper is formed? Obviously not. They do not have equal tendency to mix with each other. Okay. No reaction occurs, which is the right answer, and a lot of people, very good guys, a lot of people have given the right answer. Aluminium cannot be reduced. मतलब ये reaction अगर आप कर रहे हो CuNO3 whole twice chain plus alumine plus Al, this reaction is not gonna work. This reaction is not gonna work because copper tendency to undergo oxidation is lower as compared to aluminum's tendency to undergo oxidation. Okay, clear? Now last is the solution starts turning blue. Nope, only if Cu2 plus would had been produced in the solution तब वो blue हो जाता. जैसे ही copper sulfate वगैरह blue होता है, copper nitrate भी blue हो जाएगा. ठीक है? So the right answer is C. So electrochemistry में जरूरी नहीं है कि you are given questions based only on E0 values, but you are given such sort of like questions which would just trick your mind, and these questions are very easy to answer. Okay, very easy to answer. Chalo, let's move on to our agenda for the day कि भाई what is Nernst equation? Nernst equation की ज़रूरत क्या है? Okay, what is Nernst equation? What is the need for Nernst equation? So okay, so what is the need for Nernst equation? I had told you earlier that the E0 of the cell is calculated at a particular temperature and pressure condition and concentration condition. So when we take the temperature to be 298 Kelvin, pressure to be 1 atmosphere and concentration to be 1 molar for the electrolytes which are dissolved, what we calculate is E0. What we calculate is E0. But let's say we change the concentration or we change the temperature. What do you think will happen to the cell's potential? What will happen to the cell potential? To identify that, Nernst equation is given. कितने extent पे change करेगा वो identify करने के लिए हम नर्स्ट इक्वेशन देते हैं. So the cell potential is gonna change. Nernst equation is not just out of fun somebody has given. Nernst equation is used to account for the change. Okay, a Nernst equation is given to calculate that how much change will happen. Okay, अगर ये change कर दिया मैंने, if I change the temperature or pressure or concentration, then whatever is the cell potential, that will be calculated using Nernst equation. Okay, so it is very very important that E naught value is going to change, or the cell potential is going to change. From now onwards I'll talk about cell potential because we are working on cells. So cell potential is going to change. So Nernst equation explains the effect of concentration on EMF of half cell and EMF of cell. So it is used for explaining effect of concentration. Why we are taking concentration? Because concentration को modulate करना सबसे easy है. We can change the concentration by just adding water. We can change the concentration by adding some amount of salt. But changing the temperature and changing the pressure is slightly more difficult. We have to do the reaction in different vessel, different thermostat. I have to change the atmospheric condition. So ये दोनों चीज़ों को change करना it's slightly more difficult rather than changing concentration. So concentration किसी ने change कर दिया, how would I calculate the cell potential? That is explained using Nernst equation. Now Nernst equation समझने के लिए we will go a little behind and we start from this equation. Delta G is equal to delta G naught plus RT ln Q. Do you guys know this equation? Okay? अरे हितेश क्वेश्चन भी कभी हो रहा था ना, अभी पहले समझ तो लो थ्योरी, बिना थ्योरी समझे ही आप लोग चले जाना चाहते हो प्रॉब्लम पे. ओके, ट्राई एंड अंडरस्टैंड. अगर आप थ्योरी अच्छे समझ लोगे तो प्रॉब्लम कभी भी कर लोगे. ठीक है? सो यू नो दिस इक्वेशन, डेल्टा जी इज इक्वल टू डेल्टा जी नॉट प्लस आर टी एल एन क्यू. दिस इज द इक्वेशन वेयर वी टेक फ्री एनर्जी एंड रिलेट इट टू क्यू. क्यू को क्या बोलते हैं? रिएक्शन कोशेंट. reaction quotient. Okay, reaction quotient when we calculate at equilibrium ये हो जाएगा K. अगर इसको मैंने equilibrium conditions पे calculate किया तो वो K लिखेंगे हम. Okay, but since I'm not taking equilibrium तो इसको मैं Q लिख देता हूँ. Okay, now remember this Q is nothing but concentration of products by concentration of reactants. Whatever be the number of products, whatever be the number of reactants, that is immaterial, but this is nothing but constant ratio of product and reactant concentration. Okay, now there is another equation that you should keep in mind. I had earlier told you that delta G is proportional to minus E. Okay, delta G is proportional to minus E. If I want to write this, remove this proportionality, इसको हम लिखते हैं NFE. Okay, let me. Delta G is proportional to minus E. This will be written as minus of NFE. Okay, N represents number of electrons which are either lost or gained. N को क्या बोलते हैं? Number of electrons lost or gained. Cool. F represents number of Faradays. And E represents the potential. Okay, EMF. आप half cell potential ले लो, full cell का potential ले लो, that represents potential. So what I'm going to do is I'm going to replace delta G and delta G naught by this equation. Okay, delta G and delta G naught by this equation. Now from this equation I know that if this is positive, this delta G will be negative. If E is positive, delta G would be negative, and because of that the process will be spontaneous. Okay. So let's look at this. Delta G is written as minus NFE, and this will be written as minus NFE naught plus RT ln Q. Okay, which can further be simplified. इसको हम फिर से simplify कर सकते हैं. E is equal to E naught, sorry, E is equal to E naught minus RT by NF ln Q. Okay, N is the N factor. Yes, we can say N is the N factor. That's a very good articulation. N can be said as N factor. Shreya, I would love if you can mail that question to me, that statement to me with that snippet to saurav.goswami@vedantu.com. I'll be happy to answer you. Okay, but let's focus on this thing for now because that needs an additional explanation. Okay, so E, I can write it as E cell as E naught cell minus ln को हटाने के लिए क्या करते हैं, this is log base E, natural log है. If I want to bring it to base 10, I will write it as 2.303 RT by F. मैं इसको कॉमन ले लेता हूं, 1 by N log Q. Okay, and remember we will finally formulate it as this E naught cell. This value, you can see that there is a temperature thing over here. If I put R as gas constant and temperature as 298 Kelvin and F as Faradays, I will get this value as 0.0591 by N log of Q. This is our Nernst equation, guys. This is our Nernst equation. Nernst equation is not difficult. Remember, E cell, E naught cell minus 0.0591 by N log Q. Okay? So 0.0591 या 0.059, कभी कभार इसको JEE के बहुत सारे क्वेश्चंस में इसको अप्रोक्सीमेट करके 0.06 भी लिया गया है. Okay, but N is the number of moles in Nernst equation. No, we cannot say N is the number of moles in the Nernst equation. N is the number of moles of electrons in the Nernst equation. Okay? Clear? N is the number of moles of electrons in the Nernst equation. So this is very, very simple. Remember this equation. Now, problem ये आता है कि इस equation को use कहाँ करेंगे? Where should we use this equation? You will use this equation in certain conditions. Not in all conditions, not in all questions. So remember this. The next part is very important because that is where a lot of people make mistakes. Okay? So, which equation should we use to calculate EMF? Okay? Which equation should we use to calculate EMF? First and foremost, आप देख लीजिए इस चीज को कि when a redox reaction is given under standard condition, if you are given a redox reaction under standard condition, so सब केस 1 लेते हैं, sorry, okay, let's look at this. I hope it is not, I guess it is not visible. Okay, so I'm sorry. So when a reaction is given under standard condition का मतलब कुछ भी नहीं मेंशन किया गया है. You have not been mentioned concentration. You have just been told that standard condition temperature 298. Okay, temperature 298 Kelvin, pressure is 1 atmosphere. So sub case 1, where the number of electrons given out in oxidation, number of electrons given in reduction is equal. For example, this question. चलो एक question ले लेते हैं, random से एक question लेते हैं. A changes to A2 plus, E naught value is given as 0.71 volts. B2 plus takes up 2 electrons and E naught value is given as minus 0.6 volts. Okay, so suppose this equation, you are given oxidation potential of A to A2 plus and reduction potential of B2 plus to B. Now you can see that the number of electrons given out in oxidation and the number of electrons taken in reduction is equal. यहाँ पे कितने electrons बाहर निकल रहे हैं? 2 electrons. How many electrons are taken in? 2 electrons. Okay, कुछ भी नहीं सोचना है. अगर electrons आप same देख रहे हो, if you are seeing that the electrons are same, use the previous. This is E naught oxidation, this is E naught reduction. Add both of them. Okay, add both of them. If you see that the number of electrons given out or taken in is equal, add the E naught values. Okay, add the E naught values. ठीक है, तो यहां पे वैल्यू कितना आ जाएगा? पॉइंट माइनस कर देंगे तो ये आ जाएगा, द E naught cell will become 0.11 volts. 0.11 volts. Okay, the E naught for this is given, guys. E naught for this is given 1.71 नहीं होगा. 1.71 कैसे हो रहा है यार? E naught for this is given. So E naught for this is given, E naught for oxidation is given, E naught for reduction is given. You have to add E naught for oxidation reduction. You will get E naught of cell 0.11 volts. Okay. So electrons का number equal हो गया तो क्या हुआ? I will add both of them. Clear? Now, if the numbers are unequal, अगर number unequal दे दिया गया है, for example, you are given something like this. A changes to A2 plus, E naught is given as कितना था? 0.71 volts, and C3 plus changes to C, E naught is given as 0.52 volts, minus 0.52 volts. Okay, E naught is given as minus 0.52 volts. Okay, now this is very interesting because here so many mistakes are been committed by a number of students. याद रखो हर चीज कि E naught एक तरीका है. E naught means this value E naught निकालने के लिए the method is I am adding both of them, but the right method is using free energy. Okay, so let's go a little back and try to identify it using free energy. So how many electrons are given out? 2 electrons. How many electrons are taken in? 3 electrons. Now a lot of people what they do is they multiply E naught with number of electrons, क्योंकि what I have to do is to make the total number of electrons. देखो electron जितने निकलेंगे, the number of electrons which are given out should be equal to the number of electrons which are taken in. ठीक है, प्रीत कटियार? Yes, this is important for boards as well. So अगर हमें number of electrons को equal करना है तो हम इसको 3 से multiply करेंगे and I will multiply this with 2. Okay, I will multiply this with 3 and I will multiply this with 2. If I do that, a lot of people what they do is they multiply E naught also with 2 or 3. इस E naught को 3 से multiply कर देंगे and they will multiply this E naught with 2. You should not do that. Okay, don't ever multiply E naught with any number. Don't ever multiply it. Okay, please remember, don't ever multiply it. Why you are not supposed to multiply it is because if I calculate delta G for oxidation, क्या हो जाएगा बताइए? डेल्टा G for oxidation क्या होगा? डेल्टा G is given as minus NFE. If I take delta G for this equation, total number of electrons now after multiplying with 3 will become equal to minus 6F. This will be E naught oxidation. I will write it like this. Okay, if I write delta G oxidation, I'll write it as minus 6F E naught because total number of electrons after balancing is equal to 6. delta G for reduction will be written as minus 6 F E naught reduction, isn't it? Delta G for reduction will be written, delta G naught will be written as minus 6 F E naught. What will be the total delta G? Total delta G oxidation plus delta G naught reduction का sum होगा. So delta G naught cell will be equal to how many electrons are exchanged within the cell. कितने electrons को हमने exchange किया है? The number of electrons exchanged is 6, isn't it? 6 given out, 6 taken in. Total number of electrons exchanged is not 12. Don't add it. जितना electron exchange means जितना दिया गया 6. So this will be equal to minus 6 F E naught cell. Okay? Minus F E naught cell. I'm erasing this part. Which will be equal to minus 6 F E naught of oxidation minus 6 F E naught of reduction. 6F, 6F, 6F gets cancelled. This minus minus हटा देते हैं. क्या बन गया आपके पास? E naught cell is equal to E naught of oxidation plus E naught of reduction. So whether the number of electrons given out or taken in is equal or unequal, delta E naught of cell will always be the sum of E naught and E naught of oxidation, E naught of reduction. You are not supposed to multiply, worry about the number of electrons. ठीक है? Electrons कितने दिए जा रहे हैं, कितने अंदर आ रहे हैं, उसके बारे में चिंता करने की जरूरत नहीं है. The formula remains the same. Sub case 1, electrons whether are equal or if they are unequal, the formula remains the same. I hope you have understood, because using delta G also we have proved this. Clear? सभी को समझ में आया ये चीज? I hope सभी को समझ में आया ये. Okay? It's a, you can consider it's the only, we'll not call it general formula, we'll call it the only formula. Okay? Okay. Sorry. There's a lot of problem on the board today. Okay. When a redox reaction is not given, okay, when a redox reaction is not given under a standard condition, for example, you are given an equation, Cu changes to Cu2 plus, Cu plus changes to Cu plus, you are given E naught is minus 0.34 volts, E naught is minus 0.21 volts. Suppose this is given. Okay? So you can see that it is not a redox reaction. When a redox reaction is not given under standard condition. Okay? Redox reaction is not given under a standard. So this is not a redox reaction. Okay? When a redox reaction is not given under a standard condition, what you have to do is you will use the concept of free energy. If you are being asked to calculate it for Cu changing into Cu plus changing into Cu2 plus, आप कैसे calculate करोगे इसको? How would you calculate this? You will calculate this using the concept of free energy. Why? How would you do that? You will write it in a systematic manner. Cu plus, Cu changes to Cu plus, Cu plus changes to Cu2 plus. If you add both of them, what would you get? Cu changing into Cu2 plus. Okay? Cu changes to Cu plus, Cu plus changes to Cu2 plus. The overall reaction will be written like Cu changes to Cu2 plus. Okay? नाउ इसके लिए आपको क्या दिया गया है, Cu to Cu plus का दिया गया है, Cu to Cu plus it is given as E naught is minus 0.21. So I will write delta G1 as equal to how many electrons are given out? 1 electron. Okay, 1 electron is given out, minus F, this you will write it as minus 0.21. Clear? Next, delta G2. For this I need to calculate. Okay, for this I need to calculate, so I'll write it over here, minus 1 F, and let's say this be X. Okay? Now the total sum is delta G3, which is all, for which total number of electrons lost is 2F. What is the value given? Minus 0.34. So finally what you have to do is delta G3 is equal to delta G2 plus delta G1. Okay, delta G3 plus delta G2 plus delta G1 is del G minus NFE cell. Yeah, it can be for, it is half cell, so this is not for half cell, this is for half cell. Okay, so when I do this calculation, what I would obtain is minus 2F minus 0.34, which should be equal to minus 1F minus 0.21 plus minus 1F X. I need to calculate X. So ये माइनस माइनस आप कैंसिल कर सकते हैं, F कैंसिल हो जाएगा. So 2 times 0.34, that will be 0.68 plus 0.21. 0.68 plus 0.21 कितना होना चाहिए? 0.68 0.21, this one should be 7.47. Answer should be 0.47. Is that understood? So you will not use delta G unless and until you will not use the delta G equation, or you will not use delta G to solve your question unless and until it is either redox reaction is not given. If it is either oxidation or reduction, you will use this. If in other cases अगर आपके पास एक redox reaction दिया गया है, if it is a redox reaction which is given to you, then you will use Nernst equation if concentration terms are changed. But if concentration is not given, then you will directly use E naught oxidation plus E naught reduction without caring about how many number of electrons are taken in or given out. Okay, so I hope you have understood this. In the next session we will be discussing problems on this. Okay, problems on this, and in the, please do solve, please do read it. Today after the session, Pulkit sir will be taking the session for differentiation, and in the next session we will be solving questions on Nernst equation and voltaic cells. So please come prepared. We will have an awesome session on that very day. Okay, chaliye guys, all the best and see you in the next class. Bye bye.